Hi everyone, for today's lesson, we are going to review slope, midpoint, and distance formulas. By the end of this lesson, I would like you to be able to say, I can calculate the slope, midpoint, and distance between 2 points or ordered pairs. Those ordered pairs will be labeled x1, y1, and x2, y2. And the reason why they are labeled x sub 1, y sub 1, and x sub 2, y sub 2 is because we are talking about two completely different ordered pairs, both that will have x's and y's. So we just talk about them in terms of the first x compared to the second x, the first y compared to the second y. For today's lesson, you will need the following materials. You will need your cutout for reviewing slope, midpoint, and distance. You will need a glue stick, something to write with, and I always use colors, so I strongly encourage that you have some colors that will help you to make these clear. Also, if you would like to have a straight edge, I would recommend having a straight edge as well. It doesn't have to be a ruler, as long as it's something that, like a side of a calculator, a notebook, any sort of straight edge would be nice. So we're going to go ahead and start off by pasting this directly into our notebook. So I'm going to just paste this right in here. Zoom out just a little so you can see what I'm writing down. All right, so we're going to start off by talking about slope. And the last time we talked about slope truly was when we were in Algebra 1. So this might be something that I know that you've seen before, but let's go ahead and talk about it again. This is the graphical definition of slope, so graphing it. We know that slope is equal to rise over run, which is essentially up and down compared to left and right. So how many units are you going up and down? How many units are you going left and right? So what I have here in this picture is A and B. And what I'm going to do is I'm going to connect a segment between point A and point B. And what we want to do is we want to identify the slope of this segment. So I'm going to go ahead and zoom this in. And remember that slope is your rise versus your run. How many units do you need to go up or down? And how many units do you need to go left or right? Typically, when we're calculating slope, we always read slope from left to right. So I'm going to, in order for me to go from B to A, I'm going to count up 1, 2, 3 units. And those 3 units, I am now in line with A. So I'm going up 3 units. And now I'm going to run forward. It looks like 1, 2, 3, 4, 5, 6 units. I'm running forward 6 units. So rising 3 and running 6, I will write my slope as 3 over 6. But 3 over 6, this is my rise 3, run forward 6. So we always want to run forward if possible. So this fraction can be reduced. It can be simplified. And it can be simplified into 1/2. 1/2 is the equivalent fraction, and it is also our slope. If you analyze what we have here, if I were to start at B and rise 1 and run forward 2, so I'm going to use a different color. Rise 1 and run forward 2, I'm going to land in a spot right on the line. Rise 1, run 2. I will land at another spot right on this line segment. Rise 1, run 2, I finally land at A. So even though to go directly from B to A, that slope was 3 over 6, the most simplified form of this slope is 1/2, and that 1/2 will get you to any point on that segment. So that is something that I want you guys to keep in mind. All right, let's go ahead and talk about all of the different types of slopes that you could end up with. So in this example, we had what we called a positive slope. A positive slope means that you're going to have a positive number over a positive number. When you analyze your graph, looking at your line from left to right, it will be increasing from left to right. So it is increasing from left to right. You're going to see that it is going up. So just like reading a sentence, we always read sentences from left to right. We're going to read graphs from left to right. And in this case, because it is going up, we call it positive slope. Negative slope means that you're going to see a negative number over another number. That's negative slope. So somewhere there'll be a negative. Sometimes it's on the top, in the middle, or on the bottom, but one thing will be negative, and that fraction will simplify to be a negative number. And the graph of a negative slope, what you'll see is that that graph will be decreasing from left to right. So it is going down. The next type of slope that we have is called zero slope. And what you're going to see is that you'll have 0 on the bottom, 0 over a number. And zero slope is what I call zero fun. It is a flat, horizontal line. We have a little phrase, 0 on the top is okay, but 0 on the bottom, no way. I also have another phrase called hoy. Horizontal line. So H represents, so hoy means you have a horizontal line. 0 is equal to your slope, which slope we represent with the letter M. I think we talked about it up here. Slope is letter M. And it's going to be y equals a number. So if you're looking at an equation, you'll see that the equation is simply y equals a number, and there won't be an mx. It'll just be a number, the b value. Undefined slope, you'll see that you'll have a number over 0. 0 will be in the denominator. So like if we think of being on a ski slope, positive slope means you're going up the mountain. Negative slope, you're going down the mountain. Zero slope, you're having no fun on that mountain. It is absolutely flat. But undefined is a vertical line. It is undefined if you're going to have the time of your life or if it's going to be something that is the scariest thing that ever happened. It's undefined. So it's a vertical line. And I have a little phrase for this one called VUX. And VUX means that you have a vertical line with undefined slope. And it will be an x equals a number equation that you will be graphing. So vertical line, undefined slope, x equals a number, and you're going to see that your fraction ends up being a number over 0. Versus up here, 0 over a number will give you 0 slope. And we actually say that this is simply 0. And this one, we would simply say that this is undefined. UNDEF, period, undefined. And that's what we would say. Obviously, if you can simplify these numbers, please make sure that you do so. But 0 slope and undefined slope, that's how we simplify them. So this is the graphical definition of slope. In our class, we're primarily going to be working with the algebraic definition of slope. This is what your homework is going to be based on is the algebraic. But I wanted to make sure that I talk about it graphically before we talk about the algebraic definition. The algebraic definition is m equals y2 minus y1 divided by x2 minus x1. So what this is it's the change. It means the change in y. What is the distance or difference between the y values divided by the change in x? How did the x's change? What is that difference between them? So always make sure that your ordered pairs are lined up with each other, like y2 and x2 are lined up, and y1 and x1 are lined up. So that's another way for you to make sure that you have use the formula correctly. So what we want to do is we want to go ahead and find the slope between these 2 points. And whenever we're talking about y2 and x2, I'm going to remind you once again, we're referring to the ordered pairs x1, y1, and x2, y2. And this just means that we're talking about 2 different x values and 2 different y values, with one x and one y being one ordered pair and one x and one y being the other ordered pair. Sometimes it's helpful for students to label x1, y1, and x2, y2 just above each of the ordered pairs because it helps you to figure out where all of your pieces will go. So we are asked to find the slope between these 2 points. So we always write m equals, and that's a lowercase m, not a capital M. M equals y2, which is -2, minus y1, which is -1. Now notice it's minus -1. You don't want to, just because this has a minus doesn't mean that we negate the other minus. So you have to be consistent and watch your signs. So I'm going to write that note right here. Be consistent with your ordered pairs and how you insert it into the formula, and be careful with your signs. So I have y2 minus y1 all over x2, which is -3, minus x1, which is +3. And now what we're going to do is we are going to simplify our fractions. So I am going to make this negative, turn it into a plus, and I have -2 plus 1, which is -1, divided by -3 minus 3, which is -6. A negative over a negative makes this a positive. So therefore, my slope is going to be +1/6. And that is it. Next, we're going to review our midpoint and distance formulas. Our midpoint formula, remember this represents or calculates the center between, or the center point between 2 ordered pairs. And that center point, being the midpoint, bisects the segment. It means it cuts it in half. So midpoint, we always use a capital M, versus slope, we use a lowercase m. So you want to be careful. So the midpoint formula still works with x1, y1, and x2 and y2, but we're going to use x1 plus x2 cut in half, comma, y1 plus y2 cut in half. So what this really represents is it represents our average x value, comma, our average y value written as an ordered pair. It is a midpoint. So we write it as a point. We write it as an ordered pair. So that is something I want you to always remember, that a midpoint is a point that we write as an ordered pair, and it's an average. It's the center. That's what an average does. It finds you what that middle value is. So let's go ahead and find the midpoint. Once again, you want to make sure that you're careful with your signs, but midpoint is a little bit easier than others. So we want to find the midpoint between our ordered pairs here. And if it helps to label x1, y1, and x2, y2, make sure that you do that. So I'm going to write capital M is equal to x1, which is 3, plus x2, which is -3, cut in half, divided by 2. And then I have -1, which is y1, plus -2, which is y2, divided by 2. And we're going to simplify each of the fractions individually. So this midpoint is equal to 3 plus -3 is 0 over 2. And -1 plus -2 is -3 over 2. With our final answer being that our midpoint is located at 0, -3/2. You can also write that as 0. Or you can write it as 0, -1.5. Sometimes it is easier to write it as a decimal and graph a decimal over a fraction. Both answers are absolutely correct. There's nothing wrong with either of these answers. Preferably though, I would like the fraction, because if you had like a fraction of 1/3, writing it as a decimal is not going to be exact. So only write it as a decimal if you can write it in exact terms. Finally, we have distance formula. And the distance formula, once again, is going to use the x1 and y1, the x2 and y2. And the distance formula is d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Make sure that your answer is written in simplified radical form. That means no decimals. That's what this means right here. No decimals. The only time when you are allowed to use decimals is if the directions say it's okay for you to use decimals. But in this problem, I am going to say no. I would prefer you guys to get into simplified radical form. No decimals. So in this example, we want to find the distance between those same points that we were using. Once again, I strongly recommend labeling x1, y1 and x2, y2 to help you stay organized. So I'm going to find the distance of AB. And if you want to write D equals, you can, but because we actually know the letters, it's a little bit better and it helps you stay more organized, especially when I give you more complex problems, to write the letters AB. So I have x2, which is -3, minus x1, which is 3, squared, plus y2, which is -2, minus -1, which is y1 squared. Once again, you want to be careful with your signs. A lot of kids will make mistakes because they were not careful with their signs. So once again, we have that negative taking place here. And I'm going to change that to a plus. So I have AB is equal to the square root of, this is -3 minus 3, which is -6. -6 squared is 36. Plus -2 plus 1 is -1. -1 squared is 1. So 36 plus 1 is 37. So the distance between AB is the square root of 37. And if it was possible to write in simplified radical form, then we would do that. But in this problem, 37 doesn't have any perfect square factors. So therefore, our answer is simply that AB is equal to the square root of 37. And that is the distance between these 2 points, as well as the end of this lesson. If you have any questions over anything I just talked about, please make sure that you email me. Otherwise, I hope you have a wonderful day.